welcome back to my YouTube channel. In this video, I am going to discuss about Boit Savart law. We already studied from the Oersted principle that a current carrying conductor produces a magnetic field. Okay, but Oersted didn't say about the amount of magnetic field. How much is the amount of magnetic field and what is the expression for that? That is to be derived by Boit Savart. Okay, so what is the Boit Savart law says that? So we are going to consider the infinitely long current carrying conductor, that is X, Y, X and current I, and that is DL. This is the point R. Okay. So we are going to consider as a point B, which is R distant from a small element DL. Okay, small element DL. Okay, this current element will produce a magnetic field at this point B. Okay, from the Boit Savart's law, we can say that. From the Boit Savart's law, we can say that this dB, the magnetic field produced by this small current element, is considered as dB. This dB is directly proportional to the length of the current element, that is dl, and dB is directly proportional to I, and dB is directly proportional to sine of the angle between dl, IDL and R. This is the angle. Okay, sine of the angle between the current element and the distance. Okay, and dB is inversely proportional to square of the distance, that is from the current element to the point distance, inversely proportional to the square of the distance. This is the thing about the Boit Savart law. From that we can write magnetic field at point P. Point P is dB is equal to, dB is directly proportional to IDL sine theta divided by R square. We can change this proportionality by using an equality, by inserting a constant. What is a constant? Mu 0 divided by 4 pi. That is a constant. We are going to insert it here. IDL sine theta divided by R square. Okay, this is the Boit Savart law. Okay, this is the Boit Savart law. Okay, from this, what is I? I is the current, and what is DL? DL is the length of the current element, and theta is the angle between IDL and R. What is R? R is the distance from the current element to the point P. Okay, and what is this mu 0? Mu 0 is permeability of free space. Permeability of free space. What is permeability of free space? It is the ability of a vacuum to allow magnetic field line to pass through it. Okay, and this value is to be, mu 0 value is to be 4 pi into 10 power minus 7 Tesla meter divided by ampere. Okay, this is to the mu 0 value. So from this, what you will get? Mu 0 divided by 4 pi value, that you will get it as 4 pi cancel, so 10 power minus Tesla meter per ampere you will get. Okay, this is the Boit Savart law. In this, we have to write in the vector form. We can write this. How we can write in the vector form? So here, what is dB is equal to mu 0 divided by 4 pi IDL sine theta into R cap, modulus of the R cap into R square. Okay, This r cap is a unit vector. I am going to be inserted here. What is the magnitude of the unit vector? Unit vector magnitude is 1. So r cap is a vector which will give the direction of the r. Okay, so it gives the direction of the r. So this r cap direction is like this here. Okay, this is the direction. So we can change this equation based on the cross product. So dp vector is equal to what you get, mu 0 divided by 4 pi IDL cross r cap divided by r square repeat. Okay, so this is the cross product. From this we will get the direction of dB. What is dB? dB is perpendicular to the plane containing dl and r cap. dB is perpendicular to the plane containing dl and r cap. Okay, perpendicular to the plane containing dl and r cap. From this we can find out the direction of the line field by using right hand rule. Okay, so how you will apply the right hand rule? Place your right hand in the direction of first vector, that is dl, and curl towards the next vector, that is r vector. Then the b direction is like this. So here the b direction is going into it. Okay, this is the way we can find out the direction of the magnetic field. Okay, then what is r cap? R cap is equal to r vector divided by modulus of r vector. This I will substitute here. So what you will get? dB is equal to mu 0 divided by 4 pi IDL cross r vector divided by modulus of r will come down, so I can write it as r cube. Okay, this is also another form of the Boit Savart's law. Okay, this is also the form, this is also the form. Okay, clear? This is about the Boit Savart's law. Okay, now we will see the comparison of Boit Savart's law with the Coulomb's law. Okay. Okay. Comparison between Boit Savart's law and Coulomb's law. What is Boit Savart law? dB is equal to mu 0 divided by 4 pi IDL sin theta divided by r square. Okay. Otherwise we can write like this: IDL cross r cap we can write. Okay, clear? Okay. What is Coulomb's law? Electrostatic force between two charged particles, that is equal to 1 by 4 pi epsilon naught q1 q2 divided by r square. Okay, first we will see the similarities. First one is, this is to be a long range, this is also a long range. Okay, this is also a long range. Next, you see this dB is inversely proportional to square of the distance. F is also inversely proportional to square of the distance. So that is, two of them is depend upon inverse square law. Okay, so two things is to be depend upon inverse square law. Okay, then this is the similarities. Next we will see the dissimilarities. Okay, So here, what are the sources? dl is a vector, r cap is a vector. Here, q1 and q2 are scalar. Okay. So produced by magnetic field is produced by vector source. Vector source. Here, the magnetic field is produced by scalar source. Sorry, here not a magnetic field. The electrostatic force is to be produced by scalar source. Scalar source. Clear? Here, what about the direction? Direction of dv is perpendicular to the plane containing dl and r. Here, the force is to be along the line joining between q1 and q2. Okay? Along the line joining q1 and q2. Okay? Then next, sorry, this is to be the fifth. Here you see that this, if you expand it, what you will get? Ideal sine theta divided by r square. Is there any sine term? There is no sine term. So here we can say that it is sine theta dependence. It is not dependent. Okay, this is the major similarities and dissimilarities of Boit Savart's law and Coulomb's law.